It's time to talk about a radical way to solve quadratic equations. And that's why I'm wearing this black bandana. Or is it? The method of completing the square covered in the last lesson has been known for thousands of years across various cultures. But the method of solving quadratic equations that we're going to come up with today has only been known approximately, maybe 600 years. And we can come up with it by taking the standard form of a quadratic equation and applying completing the square to that. So our standard form of a quadratic equation is ax squared plus bx plus c equals 0. If we're going to apply completing the square to that, we need a 1x squared, and we need the variable terms on one side, the term without the variable, in this case x, to be on the other side. So I'm going to divide all sides, all terms on all sides by a. We'll still have a 0 on the other side. Then to get the variable terms alone, that gets us a 1x squared. To get the variable terms alone, I'm going to subtract c over a from both sides, so that we no longer see c over a on the left side, and we've got a negative c over a on the right side. On the side, our side work, our coefficient of x to the first is b over a, and I'm multiplying that by 1/2 to get b over 2a. We have to square that result, and we can split up the multiplication and division to get b squared all over all of 2 squared a squared. But of course 2 squared is 4. So that second step of side work is telling us what we have to add to both sides on the left hand side. But since we're adding negative c over a to b squared over 4a squared, I'm going to get a common denominator, multiply the negative c over a, multiply that top and bottom by 4a over 4a, and then that will get us a common denominator of 4a squared. But instead of writing negative 4ac plus b squared, I'm going to write that as b squared minus 4ac, all of that over 4a squared. So we've added b squared over 4a squared to both sides, and I've written what the simplified version of the right hand side will look like. Now we're ready to write the left hand side, which is a perfect square trinomial, as a binomial squared. All we have to do that is look back at the first step of side work. We've got, in the first step of side work, positive b over 2a. So that's going to simplify to the quantity x plus b over 2a. That quantity squared equals b squared minus 4ac, all of that over 4a squared. So now we can apply the square root property, and we can't forget the plus or minus. We can split up that division on the right hand side, split up the square root by the quotient rule for radicals. And when you take the square root of 4a squared, split up the 4a squared, split up those radicals. The square root of 4 is 2, and the square root of a squared is a. We've already got the plus minus accounted for. I'm going to subtract b over 2a from both sides so that it gets rid of it on the left. It'll isolate the x. And since after the simplifying of the radical, we've got that same denominator of 2a, I'm going to combine that as a single fraction. X is equal to negative b plus or minus the square root of all of b squared minus 4ac, that whole thing over 2a. That'll give us our two solutions for a quadratic formula. That last line, that is the quadratic formula.